All right, so welcome to Auth Part 2. By the end of this lesson, you should be able to verify a user's identity in Rails. You should be able to issue signed tokens to users, and you should be able to differentiate between authorization and authentication. Cool. So as I mentioned yesterday, first step of this is everything we did in Part 1. So we need to be able to create a new user with a hashed password as a, oops, I should be screen sharing. So as a reminder, these are the steps. I'm going to give you a couple minutes to do it on your own, and then we'll go over it together. But let's call it 7 minutes. See if you can get all the steps from Part 1 done. Go. Another minute. All right, cool. Pencils down. So to sanity check myself, give me a fist of 5 on how far through that you got. Fist is, I don't know what we're supposed to be doing. 5 is, I got a hash showing up. Cool, very nice. So let's walk through it one last time. Well, not last time, we're gonna do it tomorrow also, together. All right, so I'm gonna Rails new some auth project 3. Cool. Step 0, to go into the gem file, uncomment bcrypt, and run bundle install. Then I need to Rails G controller users. Make a user model. Cool. I'm going to go into my routes, resources, users, solamente. Create. Over in the controller, I will make a user. A password. And then I'm going to return it. Pro tip, since we're creating something, we can also set the status, like so. Over in our model, this is where things start getting a little different. We say has secure password. That's what's going to turn password into password digest. Speaking of which, we go over here, t-string username. We call this a password digest. We run this migration. and we're done. Let's prove that it works. Okay, fire up Postman. I make a post request to localhost 3000/users with a username and password, and I get back my created user. Yeah! Cool. So that was all the first part. Second part, we want to start looking at being able to verify a user's identity. So here's the steps. We're going to create a login route. We're going to create a login controller and action. We're going to look up a user. We're going to authenticate them, and then we're going to create a token and send it. So let's look at these first four first. This is one of the things that's a lot more manual in something like Node. We got magic with that has secure password, that bcrypt gem. That's going to do a lot of the work for us in Rails. It's delightful. Well, let's follow the steps. Again, don't follow along with this. You'll get a chance to do that. Just watch. We're going to create a login route first. So I go over to my routes, and I'm going to call this post. Any post request to login should go to the authentication controller's login action. As a reminder, we don't have to just use resources. We can also specifically say this HTTP method to this path goes to this controller's action. Next, we're creating the login controller in action. So we're going to call the controller authentication. We're going to call the action login. So I'm going to Rails G controller authentication. I'm going to go into that authentication controller and make a login action. Cool. Then I'm going to look up a user. So I'm logging in with a username and password. So I can say the user is user.find by username params username. What does it mean if I can't find the user?
They have not made an account?
Yep. So we could say something like if not user, I might do something like render JSON error, no user with that username, and then unauthorized will be the status code on that. It's a 401. All right, cool. So then the next step is we want to authenticate them. So this is where we get some magic. So if we're in this else block, it means that we did successfully find a matching user. The next thing we need to do is figure out whether or not their password's okay. So they're sending us the password in plain text. We haven't stored the password in plain text though. So how do I square the circle on that? How do I figure out whether or not they send me the right password?
Well, it's going to get scrambled when they enter it, so we're matching that result to what we have in the database.
Correct. We're going to hash their password. We're going to look up their hashed password. We're going to make sure they're the same thing. Luckily, we don't have to do that by hand. There is that has secure password macro gives us a method called Authenticate. And we're going to pass in to that the password they gave us. So that's going to return something truthy if it works and something falsy if it doesn't work. So I could do something like bad password, brah. Which means if it made it through both of those things, it might say something like maybe something like that. Let's look through this maze again. We look up the user. If the user doesn't exist, it means they didn't give us a good username. If the user's password doesn't authenticate, they gave us a bad password. Otherwise, it means it all worked. So create a login route, login controller and actor. We looked up the user, we authenticated them. That's the first 4 steps of this. Let's see it in action. All right, so I've got this username and password. If I change it to post login, you're logged in, bud. Cool. What if I get the username wrong? No user with that username, 401 response. What if my username is right and my password is wrong? Bad password, 401 unauthorized. I do them both right. I'm logged in. Ask me some questions about this.
Beyond, this is not really a question, to comment. Beyond learning the syntax, it seems fairly straightforward. Is that, kind of the way it is the rest of the way, or does it get more complicated?
This last step, signing a token and sending it back, yeah, that's like a little bit more complicated than this, but no, it's not rocket science. The thing is, by the end of the 3rd step of this, there's like 12 steps in this process. You'll just have done them a lot, and so you'll know it.
Is a message just a positive coded error?
Yep, kind of.
They're both like just, hey, this will show up to the user.
Well, they're just, that's the thing that I'm sending back.
Oh, it's literally just a label in the
Correct.
object. Okay.
You got it. Cool. So now we need to talk about creating a token, signing it, sending it. This part's a little bit gnarlier, just a little bit. So first step is, well, actually, let's pause for a sec. Let's talk about what tokens are. The way that we're going to handle login, there's a few different ways, 3 like fairly popular families. This is one of them. This is token-based authentication. How it works is I give a username and password to the server. They give me a token. Token is like proof that you gave me a good username and password at some point. And then you're going to send the token with all of your future requests. You're not going to send your username and password every time. You're just going to send the token. It's like a valet key. It's like, oh, no, they gave me the key to the house or whatever. Or like a hand stamp at a club. That's what a token is. What's kind of cool about tokens is that you can also store things in the token. It's just a hash, basically. So we can put a user's shopping cart, we can put their username, we can put all kinds of shit, and we can send it back to the client. Client's going to hold on to it, send it back on every request. But tokens aren't encrypted or anything like that. They're encoded, which, if you remember, there was 3 different things in the cryptography family we were talking about. Yesterday we talked about hashing. Today we're talking about encoding. Encoding is Pig Latin. It's just as easy to go one direction as the other direction. And the specific kind of token encoding that we're going to use is called Jot. I'm not having a stroke. I know that it's written JWT. I'm telling you, it's pronounced Jot. I don't know. I didn't make it up. That's how it's pronounced. So Jot is a JSON web token, and they look like this. Just some characters. It's got a couple different sections to it. This section is the header. This section is the payload. And this section is the signature. So I mentioned that this is Pig Latin. This is what's called a Base64 encoding. What's Base64? Anybody know?
Just a guess, 64 bits?
It is. What's that mean?
It's a amount of binary, right? A bit is like an individual character in binary.
Yep. So what do you think a Base64 encoding is then?
Breaks it up into 64 bits. And that's...
Does it have a combination of like 2 to the power of like 16 or whatever it is?
Say that again?
Does it have like a combination of like 2 to the power of something?
Yes.
Like, is it like 8 or 16?
Kinda. So like, let me ask the question differently. What's base 2?
Binary?
Binary. What's base 10?
I forget, I don't know.
Decimal. That's like our normal counting system is base 10. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you start all over again, and you just put one more number over to the side. So binary, all we have is 1 and 0. Base 10, we have 0 through 9. In base 64, we have 0 through 9, lowercase a through lowercase z, uppercase a through uppercase z, and underscore. I feel like dash might be allowed also. There's 64 different things that a single character can have. So it's a way to do binary, but binary only has 2 values. We can send any characters we want. So if each number can have 64 different values, we end up with that. So they'll let you play with this. If I watch how this changes on the left as I type, it's just a 1-for-1 match to these. This last part bears some special consideration. So what happens with this last part, this is a signature. This is yet another use of hashes. So what we're doing with this is we take the first two parts of this, the header and the payload, and we hash them. And we hash them with a top secret key that only I know. And then the resulting hash I put as the last part of this. Because since this is just encoded, it's not encrypted, your users can see this stuff. You get a token, it's running on your computer. You can open it up, you can modify it. You can say, no, I'm not Kyle Coberly, I'm the aggressively Polish Ben Dunn. And if I hand that token back to the server, then they go, shit, I think this has been done. So the way that I keep that impersonation from happening is I sign the token. I take the header and the payload and I hash it, and I keep that hash here. And one of the things that I'm using to hash it, only I know. The client doesn't know it. So if they fuck with the payload, that's going to generate a different signature. So the signature won't match the header and the payload. That's how we keep our tokens from getting tampered with. Pretty cool, huh? So let's see how it works in Ruby. First step is we need to install the Jot Gem. So this one doesn't actually get like auto loaded. We need to do it by hand. So down at the bottom, I'm just going to say gem Jot. That's it. I'm going to bundle install. So now I have a class called JWT that I can use wherever. So over on this authentication controller, everything works out good. Awesome. Now what I want to do is make a token and sign it. So what I'll do is I'll make a payload. And I can put anything I want in this payload. Probably the most common thing is like a user ID, because I can use this to look up the user when they give me the token back. Make sure that they're allowed to do whatever they want to do, or I can use that to assign something to a user. It's my evidence that somebody is who they say they are. So I'll say, all right, user ID is @user.id. I can also put an expiration date. And like, oh, and by the way, this token is only good for the next 24 hours. And then if somebody tries to modify that so that it's good for a week, the signature doesn't match. And so I know that they fucked with it. Okay, so I take this payload, and now I want a top secret. For right now, I'm just going to say top secret like that. There's actually one that Rails auto-generates. I'll show you how to use in a sec. But right now, we're just going to make up a password. And then I'm going to do, the token is jwt.encode the payload with the secret. And then what I'm going to do is just send it on back like that. Ta-da, done. So I'm going to put one more thing in here to make this next part more dramatic. Okay, so I make this payload, I make up some secret, I encode the token, I send it back. See if it works. So I run my server, I go over to Postman, I get this token back. Huh, weird. I wonder what happens if I plug this into the Jot website. There we go. Successfully encoded. Awesome. That's the second step of our auth process. Make a login route, make a login controller action, look up a user, authenticate them, make a token, sign it, send it. Ask me some questions.
So a token is a further measure to ensure that you're getting the right people and
So a token is to keep them from having to send their username and password with every single request.
I see. So when I log in, it's like, oh, word, that's this token. We just have to match that instead of match username, match password.
Every time, right?
Got it.
So when you're trying to, I don't know, add a new favorite Pokemon or whatever, you're going to send your token over, and I'm going to look at the token and go, okay, this is good. Also, this is Ben. Cool, got it.
So realistically, when I create a new username and password on some website, is that the only time that that verification is happening, or like the first login is the only time that that's happening?
It's every time you log in.
Right. But so I've created a user and a password. I've logged in. That time it is checking the username, checking the password, issuing a token, and then every subsequent time it's just using the token.
Every like subsequent action you take while you're logged in, you're sending a token. Your token still can expire, and then you have to log in again, at which point they're generating a new token for you.
Okay, so the token is more like the username and password are like a superficial kind of check-in, where being on the website at all is really what I'm like being authorized to do, and the token gives me that authorization.
Yeah, think of it like a bouncer and a hand stamp at a club. You pay your admission, that's logging in, and then they stamp your hand. And you can come in and out until your stamp wears off.
Got it. So this is why I don't have to log into Facebook every time I go there unless I deliberately log out.
The reason that that's the case is that Facebook doesn't expire your tokens. The thing they do is actually a little bit more complicated than that.
So they could say have a month expiration on that token, and I would be like, cool, January 1st, log in. And then it, February 1st, it's like, hey,
Right.
man, you have to log in again.
Correct.
Okay.
Yeah, that's accurate. More questions about verifying a user's identity and issuing signed tokens?
Can we see just your code again, where you create it?
Absolutely. Look up the user by their username. If they don't exist, no user. If their password doesn't match, and I'm using that magical authenticate method that got added to the model instance, then they didn't give me a good password. If neither of those things are the case, that means it was a good username and a good password. So I make a payload, I get a secret, I make a token, send it.
And the login is a post request? Or what was it on post?
It doesn't have to be, but it most often is.
Okay.
It could be anything. It could be a patch. It could be a delete for that matter. But it makes sense to not do a get, because get requests are bookmarkable. Probably don't want that to be bookmarked. Common question I get, why negate these? Why not do if user and if user.authenticate? Why if not user and if not user authenticate? The rationale behind this is that by doing these negations, our happy path, which is like, if everything goes right, this is what should happen, is the last thing in the method. That makes it easier to read. Imagine if I flip this around, I'll say if user and if authenticate password. So then this part is going to end up going in here. This part is going to end up going in there. This part ends up going there. Yeah. So if I don't do the negation, it ends up looking like this, with the part that I actually care about in like the very middle of the method. I think that's way harder to read than that. Is their username right? Is their password right? Make a token, sign it, send it. Cool, let's do it together. So I'm going to Rails new some auth project 4. Oh shoot, I don't want to do the entire thing. Fuck. I'm going to go to some auth project 3. We go to the gem file. We're going to undo everything. By and cool. I think that was it. Yeah. All right. So, Ben, give me the first step.
We need to, yes, create the login route.
All right. What's my login route going to look like?
Post login to, I think it's authenticate.
Authentication.
Yes, and then pound login.
Cool. Very nice. Michael Navoy, give me the next step.
Generate your controller.
Cool. It technically already exists, but it would be like that, right? All right, I made it. Lynn, give me a next step.
I'm sorry, I got caught up debugging a hang up in my terminal and I sort of got behind.
All right. Haley, give me a next step.
We need to go to that controller we just created and create a login method.
Beautiful. Okay, Matt Long, give me another step.
I'm not sure at the moment.
Okay. Find where we are on that list. Made a login route. We created a login controller in action.
Look up the user.
Okay, how do I do that? They gave me a username.
Something about matching their token.
Oh, not yet. All I'm doing, so this isn't even like Authy kind of stuff. This is just regular active record. I'm trying to find some matching instance of a model. So I don't do find, because find would be if I have their ID. I don't have their ID. I have their username. So how do I find by a particular property?
Are you doing find params ID?
Almost. It's find by and then params. And what did they give me?
The username?
Yeah. Say username is whatever username that they send me. All right, Sam Evans, give me the next step. Unmute.
We authenticate this user that we found.
So before we authenticate, so that's going to be checking their password. There's something we can do right off the bat that before we check their password, we need to check that what?
Oh, that the user exists that we actually found.
Yeah. So what do I type?
I don't know.
Okay. So if this didn't match anything, it comes back as nil.
Right.
So what do I do?
You could say if user do something, if not, send an error or render an error.
Yeah. So I can do if user, and I just talked about a particular pattern with this that I think makes it easier to read. Do you remember what it is?
A ternary?
Oop, doing it backward.
Ah.
So if not the user. If I don't find a user, I want to render JSON. Something like that. Cool. Ben Dunn, give me a next step.
Are you carrying on with this method, or are we installing
So I looked up the user.
Cool, so we're carrying on with the method then.
Mm-hmm.
Just unmute my damn self. We can render JSON on that if to let people know.
So this means that the username existed. What happens in here? So if the username exists, what's the next thing I have to check?
If their password exists.
Yeah. Well, if their password is the same one that I got sent.
Yeah, or
How do I do
rather
that?
if it's, yeah, not the password.
Yep. Love it. So how do I check their password?
Dot authenticate params.
Yep. So authenticate, and then which param am I authenticating with?
Password.
Yeah. So if their password doesn't match, then that's this error. If neither of those things is the case, that means their username was right, means their password was right. Michael Navoy, what do I do next?
So if we have our password correct, or username correct, start creating the token.
Yeah. So how do I start creating a token?
Uh,
Two ingredients,
payload and secret.
payload and a secret. Okay, so what's the payload?
Still me?
Yep.
Like user ID or underscore ID is equal to @user.id.
Beautiful, very nice. And then what's the secret?
Could it just be anything? But last time you had top secret. So
Yeah.
I don't know if it's. Okay.
Now, I mentioned, we'll talk about this, I think, in the third one. Rails gives you a built-in secret that you can use, but it's just a string like this. Cool. Lynn, do you know what I do next with these two things?
You take them over to the JWT website and get a Jot token.
Oop. So the Jot token will let me inspect one. I don't need to use the website to make one though. It's going to make one every time somebody logs in. But you're on the right track.
Oh,
You
you need
remember-
to add JWT gem to your gem file.
You're beautiful. So yeah, I can say gem, Jot, and then what do I do next?
You have to bundle install because you just
Yes,
added
I
a new
do.
gem.
Correct. Very nice. Haley, what do I do next?
We want to go back to our method, and after secret, we want to add token equals jwt.encode payload, comma, secret.
Yep.
What was that pronunciation again?
Jot.
Jot.
Cool. So I have a token now. Matt Long, what do I do with it?
Do you need to assign it to the user?
It's signed. So that's what the secret does. The secret signs it.
I'm not sure.
Take a look at the other ones. That. I need to send them back something.
I'm not sure. I wouldn't think that you would render JSON. You wouldn't want to show the token.
You absolutely want to show the token.
Yeah.
That's what they're going to use to log in from now on, or until like your token expires.
Okay.
So we want to send it back to them so that they can send it back to us every time they want to do something. This is stamping the hand at the club. I look up the user. If the user doesn't exist, then they didn't give me a good username. If the user's password doesn't match, then they gave me a bad password. If neither of those things are true, then their username and password were good. I make a payload. I take a secret. I make a token. I send it back.
So why are we sending back the token if they can just log in with their username and password? Why do they need it?
Because then you would need to send your username and password with every single HTTP request that you make. So every page you click on, everything you try to do, you have to send your username and password.
So that token just hangs out with them while they're in your web app until they log out?
Yes. So instead of sending a username and password every time, we send a token. The token takes the place of a username and password after I've already verified that you did that correctly.
When we send the token, does the user actually see it, or are we talking more like a cookies situation where it's just
This is
on
an
their computer?
alternative to cookies.
But it's a similar concept where it's just stored somewhere on my.
Almost the exact same concept.
Gotcha. Because I was like, I've never fucking seen a token.
So let's try to think of something that probably has.
Hey, Kyle, what was that catchphrase in the Jot website?
I was just proving that you can put anything you want in there.
Oh.
It was not the mama.
All right, so if I go over to Heroku and I pull up DevTools and I go over to storage, there's my token. So every time I do something on Heroku, like, all right, I want to see the Develop Denver site. I'm going to, with every one of those, if I look at the request headers, hey, what do you know? There's that token. I didn't have to log in again when I clicked that link. I don't have to log in again when I click here. I don't have to log in again when I click this. I just send the token every time. Other questions? Cool. For step 3 tomorrow, we're going to talk about, all right, so you send a token over. What do you do with it? How do you know that you got a good token? And how do you protect some action in a controller so that only somebody with a token can call that action? And just like today, we're going to start with parts 1 and 2 right up at the top of the lesson. So today would be a mighty fine day to do some build and burns on the things that we just did. It'll probably be a second before I get this video up. The good news is you have lots of other ones. They're all exactly the same. Cool. Any other questions? Have a good lunch.